Hello and welcome to our latest Peel Hunt, Renewable Energy and Clean Tech podcast. I'm Nick Walker, Peel Hunt's Head of Renewable Energy, Clean Tech and Sustainability Research. Delighted to have with me today Phil Caldwell, CEO of Ceres Power. Good morning, Phil.
Morning, Nick. Nice to see you again.
Phil, the last time we recorded a podcast was back in sort of mid-March, about 8 months ago. It was shortly after you announced your Delta Electronics of Taiwan dual licensing deal for SOEC and SOFC stack manufacturing. I think it's fair to say that operationally and commercially, 2024 has been a pretty stellar year for Ceres. One of your best, in fact, I would say. Not least, you reported that as of 31st of August, you'd booked about £103 million of new order intake, and that was just to the end of August. And obviously, you've signed a number of license deals and some really interesting follow-up partnership projects since then as well. The key new milestones that you've signed since our last podcast would be the SOEC stack license with Denso. That was back in August. You signed a system license with Thermax of India in September. With Shell in June, you signed a contract for a 10 megawatt pressurized SOE electrolyzer system. And you've been working very hard with Atkins Realis on the design for 100 megawatt plus electrolyzer systems. So a lot to unpack there, which we'll go into in a minute. As a first topic, though, for our discussion, I thought it would be good if we could just do a brief recap of the unique selling points of Ceres' technology. And want to look at it both from a CapEx and an OpEx positioning, because clearly, and we're seeing this a lot in some of our thematic research, the economics of the system are being absolutely coming front and center of whether projects are getting to FID or not. We've seen a lot of projects across steel, petrochem, fertilizer, chemicals, and other sectors being proposed, a lot of work being done on them, many of them getting subsidized, subsidy sort of positioning, and then later some of them fizzle and die and don't get off-take contracts, or and a lot of that comes down to the economics. So I think economics are fundamentally quite important. What I'd really like you to do, if you could, is if you could just run through the fundamentals of the USPs of the Ceres system for our audience. In particular, looking at your technology around the CapEx, low cost of the materials you're using, and the OpEx in terms of high efficiencies you can achieve to ultimately get to a low levelized cost of hydrogen.
Okay, sure, Nick. So first of all, we'll start with the Ceres technology, but then don't forget this is part of a wider offering. Ultimately, this all comes down to a levelized cost of hydrogen or levelized cost of power if it's a fuel cell, or levelized cost of ammonia or green steel at the end of the day. But the reason that more and more partners pick the Ceres technology is fundamentally we have a low-cost, high-efficiency technology. And that's based upon the steel cell construct. So 90% of the actual cell itself is conventional steel that you would find in the automotive industry. And we operate at what's called an intermediate temperature. And for listeners, that gets a bit technical. But a lot of our peers are at a very high temperature or much lower temperature. So we operate in the 500 to 600 Celsius range. Some of our competitors are as high as 800 to 900 Celsius, and others are sub 100. And what that temperature range does for us is it allows us to use these conventional materials, and it means we avoid expensive alloys that you would need at higher temperatures. And we also use everyday ceramics. So we use cerium as our electrolyte. That's the most common of all the rare earth materials. We avoid, in electrolyzers, precious metals, so PGM group metals. We avoid things like iridium totally. So we just, by design, we avoid a lot of these hard-to-source, expensive materials. And because of that temperature range, the rest of the system is also able to be made from conventional materials, and we're able to use conventional automotive-type gaskets, etc. In the manufacture of the technology, because it's very easy to handle, because ceramics, solid oxide is a type of ceramic kind of material, that can be quite hard to manufacture. When you're talking about steel and printing layers on steel, it's a lot like the chip industry or the photovoltaic industry. So we're able to use equipment that's off the shelf and is highly scalable. And so companies that are looking to get into this market, they look not only at the performance of the technology, but the manufacturability of it, the supply chain of it, the sustainability of it. And that's where we have a lot of advantage. So that's fundamentally on the CapEx side of the Ceres technology. Now, I mentioned about low temperature and high temperature. One of the advantages of solid oxide as a higher temperature technology is we can be more efficient than technologies that exist today, such as alkaline and PEM, which operate below 100 Celsius. And the reason that we're more efficient, well, A, we're more efficient anyway, but if we can actually substitute electrons for heat, we actually get about a 25% greater efficiency than lower temperature technologies. And that greater efficiency means you need 25% less energy to produce a kilogram of hydrogen. So we're targeting now 36 kilowatt hours of electricity to make 1 kilo of hydrogen, whereas that low temperature range technologies are all around the 50 kilowatt hours per kilo. So that's quite significant in terms of the energy bill to make that kilo of hydrogen. But also, if you just think about the number of electrolyzers you actually need 25% fewer electrolyzers to make the same amount of hydrogen. So you're saving CapEx that way. But what's often overlooked is you also need less upstream capacity for renewables to produce the same amount of power, because your power is producing more hydrogen because it's more efficient. So that's ultimately quite a compelling proposition when you go to an end user who's interested in something like green steel or green ammonia or synthetic fuels. They're not really looking at the cost of the electrolyzer on its own. They're looking at the overall economic case. And because of its high efficiency, that has a big knock-on effect into the overall economics of the end product that you're making, which is the levelized cost of hydrogen or ammonia or the end product. So that's fundamentally why we have this big advantage in the market.
Great, thanks for that. It's a really good recap on the USPs of the tech, both on the CapEx and the OpEx side. Let's move on then to talk about the business model, because you are a differentiated business model for most companies that are on the market that people will recognize. Obviously, Ceres is a licensing business model. What we've seen over the last sort of few months in particular is that your licensing business model has come on leaps and bounds, and you actually now have 7 licenses in the market. 4 of those, of course, being stack licenses. That's with Bosch for fuel cells in Germany, Doosan for fuel cells in Korea, Delta in Taiwan for fuel cells and electrolyzers, and latterly Denso for electrolyzers in Japan. And then you have your system partnerships with Weichai, with Thermax in India, and Doosan. So the platform now is really being set out geographically. You're in quite a wide range of jurisdictions. It's notable, obviously, that quite a few of those are in Asia, covering South Korea, Taiwan, Japan, China, and India.
Yep.
I'd like you to sort of look at that a little bit. Let's also look at the state of the hydrogen market as well, and particularly, we sit here today, obviously, a few days after Trump has been re-elected. Obviously, you have people on the ground now in multiple jurisdictions working with your partners as they build out, having licensed the technology they're manufacturing, or starting that process at least. What are you seeing, what are you hearing as you travel around your different partnerships, obviously talk to your business development and partnership colleagues about the state of the market? What are your expectations? Do you think you'll have good insulation, being predominantly in Asia at the moment, from any sort of Trump rollback scenarios?
The model that we have is a licensing model. And we believe, look, if we want to have any chance of achieving net zero by 2050 and avoiding temperature rises, which are already catastrophic, we've got to scale at pace. And the way that we scale this business is simultaneously through licensing into the markets where we see the biggest demand. So we follow the market, really. I think it's no coincidence that this year we've been successful, maybe where others haven't, because I think that people who are now thinking about entering this market are looking at some of those attributes I just discussed, which is if you're going to invest in technology now that's going to scale in the 27, 28 period and really come on stream towards the end of this decade and into the 2030s and beyond, you're going to go with the highest efficiency, lowest cost. And I think we're seeing solid oxide as a technology in general coming on in leaps and bounds, not just with Ceres, but some of our competition as well, which is good. And I think a few years ago, it was dismissed. Oh, you guys are going to be too late to the market. It's all going to be alkaline and PEM, etc. And solid oxide was viewed as a little bit of it's still in the lab, it can't quite scale. That narrative has shifted dramatically. Now, I think what we've seen in the hydrogen market is that classic Gartner hype cycle. We all got very excited. Hydrogen was going to be all things to all men. I think, we've had this doldrum, if you like, of, things are taking longer, things are getting cancelled, etc. And the market for hydrogen, I think, has come in terms of what is the real size of the addressable market for hydrogen. But again, if you're going to hit net zero, there's certain parts of the economy that are not going to be taken purely by electrification, and you are going to need hydrogen to decarbonize. And that's really where you're taking green electrons and making green molecules to decarbonize things like steel in our buildings, the fertilizers that we need for food production, things like our building materials, and synthetic fuels for things like aviation, and maybe even things like synthetic gas to displace what's already used today. So the good news, I think, from our technology point of view is that is bang in the sweet spot of solid oxide, because all of those hard to decarbonize industries can be coupled with the Ceres technology, thermally integrated using heat from some of these energy intensive industries to give very high efficiency, low cost hydrogen. And when we look globally, if you look at who are the biggest carbon emitters, who have the big industries, don't forget, we've offshored a lot of our manufacturing industry to places like China, like Taiwan, like Korea, like Japan, like India, and that's where we're seeing a lot of the market potential. Also, when you ask me what I see when I go out with the biz dev team, etc., these companies are incredibly capable. I mean, what they do already in industries like chip manufacture or solar PV or battery manufacture is building world-scale factories, highly automated, almost lights-out kind of production. Our business model leverages all of that expertise. And I think that's why this year we're probably booking the trend, really, in terms of our results are up, our number of licensees are up, whereas people who are already in production now are fighting for orders in a market that has somewhat disappointed, let's face it, in the last year or two. So we are very much focused on signing new license partners and scaling technology which will come on stream in the next few years. And I think our timing on that is excellent. I think also the world economy is changing. And you talked about Trump. We're seeing a lot of protectionism, and it's getting harder, I think, to be a conventional manufacturer. It would be almost impossible for us to imagine ourselves as a UK manufacturer that's going to export to US, India, China, etc., without any tariffs. Whereas actually, maybe it's timing, but now our business model looks like the winning model, which can actually, if you want to export technology from the UK, licensing it across borders and having it not only be manufactured locally, but also addressing these huge local markets, is a way for us as a UK company to capture the big opportunity of decarbonisation, which is a $1 trillion market.
So you have true tariff insulation, is what you're saying.
We do, yeah.
Fascinating. That's really fascinating. Let's take a little bit of a deeper dive
Sure.
into some of the new milestone announcements you've made since we did our last podcast. As we said, the last one we talked about was Delta. Let's start with Denso. It's an SOEC stack license in Japan, announced originally without the name in July, and then obviously with the name in August. Denso as a company, I didn't know too much about it. I think quite a few other people, unless they're in the automotive parts manufacturing business, wouldn't know. But it is a major automotive manufacturer. They're very big in manufacturing powertrains, climate control systems, safety systems like airbags, etc., and electric and electronic systems. The company is almost 38% owned by Toyota, which itself potentially could be quite interesting down the road. I understand, however, that Denso did have their own solid oxide technology, which they were developing or have been developing over the last sort of few years. I'm interested to understand if or why, in fact, Denso have adopted your technology, notwithstanding that it's a good technology, clearly. Is that now going to sort of supersede theirs? Is it going to sit alongside theirs? Or how is that going to play out? The other thing I think I'm very interested in is what sort of time frame you think Denso might be up and running. Obviously, when you announced Delta, you said they were wanted to be quite punchy in terms of time frame of getting to the market. Is Denso similarly wanting to act at some pace? And what sort of application markets do you think their technology could ultimately be used in?
There's a couple of things to unpick there. You're right. Denso, like several Japanese companies, has been developing solid oxide technology for over a decade that I've known them. I mentioned at the beginning, one of the big plus points of our technology is we're not making an all ceramic type technology. We're making something based on steel which can be mass manufactured. And I can't really speak here about Denso's plans for their own development, but I think what's happening with solid oxide is we're now getting to a point where we're entering into scale-up. And we're entering into scale-up because governments like Japan are now putting significant public and private money into this. So Japan announced 15 trillion yen, just under $100 billion over the next 15 years into scaling up green technologies, including hydrogen, and encouraging companies to lay down capacity, like everywhere else in the world right now. The decision I think that a company makes at that point is what I've been developing ready to scale or not? And if it's not, then you have a make-buy decision. And really, when you look around, Bosch, Denso, Delta, Doosan, there's a growing number of people that are all choosing the Ceres platform. And from our point of view, we kind of want to get to like an Intel Inside kind of platform where we are the technology of choice. So I think what's behind the Denso decision is when they came and look at our technology, they recognize something that can be scaled and that others are scaling as well. And that gives a lot of confidence. And when we do a technology transfer, we can show them our pilot facility in the UK. We can also show them our supply chains. We now benefit now from existing licensees' supply chains as well in Asia. So we're getting this compounding effect of more and more experience that we harvest from our license partners and also growing these supply chains. So I think the big reason that people are now deciding on the Ceres technology is it is ready to scale. And I think that's in contrast to maybe the state of development of some of the other high temperature technologies, which are less readily scalable.
Just briefly then on your understanding of Denso's sort of timelines to bring the technology to market.
Unlike Delta, they haven't been public on that. Normally, from signing to production is, in Delta's case, that was 3 years. That's quite punchy, as you say, but that's from developing the product and laying down factories. So it's going to be similar or something akin to that, I would imagine.
Okay, great. Let's move on then to Thermax. It was an SOEC system license this time with Thermax. Thermax is an interesting company. It's obviously a listed company, market cap around $5 billion or so. And it's a very established manufacturer in India of process equipment for a number of hard-to-abate industries, which obviously tallies very closely with the markets that you want to get into with electrolyzer technology, and that includes, of course, green ammonia, petrochemicals, and steel. It was interesting to note from the announcement back in September that they're going to be making what they called a first-of-a-kind pressurized SEC module, so I'm keen to sort of understand a bit more about that. India, clearly, we've heard quite a lot about from a hydrogen context recently. Prime Minister Modi inaugurated the second international conference on green hydrogen in India in September. It was a 3-day event. I remember hearing on the news that he had a room of 7,000 industrial players, which he was talking to. And it was indeed, I remember very vividly, Modi encouraging the rest of the world to get on the green hydrogen bandwagon, which was great to hear, obviously. The National Green Hydrogen Mission in India, they're planning for 5 million tons of hydrogen by 2030. And they also see a great opportunity, don't they, of producing and using hydrogen in India, but also potentially as a major export producer for the rest of the world as well. So clearly a great place to be partnering with a major player who's already involved in those industries. First question would be, how did that relationship come about? Obviously, we know that you're trialing with Shell in India. Was that a relationship introduction? Was that deal relatively speedy to do? And how scalable do you think the opportunity is for Ceres getting into these hard-to-abate industries through the Thermax relationship?
Exactly what you outlined there, Nick. India has a huge opportunity from an economic point of view. And going back to the business model earlier, not every region of the world has the same kind of opportunity. And in Europe, particularly in the US, they have existing economies built upon fossil-based energy that they want to preserve. And I think that's why we're getting a little bit of the protectionism that's coming out there. If you're India, you're a net importer of most of your energy, and you have been for some time. But if you have this opportunity based on abundance of renewable energy, you can go to being a net exporter. And I think that's why Modi is pushing it so hard, and that's why it's a clear target market for Ceres. And recognizing that, we've had people on the ground in India for a number of years now, from a business development point of view. We're obviously supporting the Shell activity in Bangalore, but the Thermax relationship came about through our own business development activity. I think the proof point of Shell in India also helps. That's going to be the first solid oxide unit in India. But it really comes down to our relationships in terms of building opportunities on the business development front in India. So I think on the question about it's pressurized, etc., Thermax is a different kind of licensee than our stack manufacturing licensee. So when we think about the whole value chain, somebody like Shell is unlikely to manufacture our technology, but they have a clear economic case if it gives them a lower cost way to a synthetic fuel or to green ammonia, etc. And then in that value chain, you will have EPCs, you will have equipment suppliers, and then you'll have stack and cell manufacturers. So we need people like Thermax in our offering, and for those guys are a logical choice for us because they make a lot of process equipment around thermal integration. They make chillers that you can combine with fuel cells as well. They make a lot of boiler kind of equipment. So they're well established in the industry, and from a diversification point of view, they see this as a growth market, and they see the solid oxide technology as being highly synergistic with what they offer already. So they're aware that we are developing system capability on our next stage of that is with Shell on the concept of pressurized solid oxide. And obviously, what we license to Thermax is a design that then can be made to high quality, but in a low-cost region of the world. And I think that's the other thing here is, in our supply chain, having somebody with Thermax's capability is very valuable in the future in terms of some of the equipment manufacturing that can come on at high quality and low cost.
Fantastic. You mentioned Shell a couple of times there, so it's a good segue into talking about Shell. You deployed a 1 megawatt demonstrator unit with Shell at its Bangalore R&D facility earlier in the year. You said that's going through kind of final commissioning now when you had the interims recently, and is scheduled to come online fully, I guess, before the end of this calendar year. You announced a contract, an extension of your Shell relationship to design a 10 megawatt electrolyzer unit, and with this target of producing hydrogen at less than 36 kilowatt hours per kilogram. I'm interested, just first of all, to talk about what learnings you've had so far over the last sort of 3, 4, 5 months that the unit's been on the ground there, and what gave Shell the confidence to move to this next step. Is this contract to design only, or are you actually going to build and deploy a 10 megawatt unit for Shell, either in India or elsewhere? And what's the significance of the 36 kilowatt hours per kilogram figure? Do you think that will be a world leading in terms of sort of energy use and hence cost of production?
Yeah, so let's start with that figure. It will be amongst the lowest that there is available. I think what happens is you actually get to a theoretical minimum. I think at a stack level we can get to as low as 34 or thereabouts, but then you hit the natural limits of the thermodynamics and the physics. And then obviously then it's about the system efficiency. But in the first testing we've done with Shell, we've already proven before we even shipped to Bangalore in testing in Germany, numbers around the 37 kilowatt hours per kilo, which are for competing technologies are miles better. But 36 would be industry leading, world leading. But it's not like you're going to get lower and lower and lower. You're going to hit a minimum at some stage, and that's where that's where we think is a sensible target. The pressurization is interesting because I'm not aware yet of anybody doing pressurized solid oxide. And we've done work with Colorado School of Mines previously on pressurized SOFC. So we're very confident on this. We have a collaboration in the US on this development. And bringing that into EC is important because people want pressurized hydrogen. We've seen that in pressurized alkaline, pressurized PEM, some of those competing technologies. And even if you just pressurize to a relatively modest pressure of a couple of bar upwards, you can avoid the first stage of a multi-stage compression on a chemical plant, which saves you, again, a lot of capex elsewhere. So Shell's very interested in this concept. That's where we were going next, so we've decided to collaborate on the design. Not yet the build, but the design of that with Shell. However, those modules we are building now. So from that design, Ceres is building those modules, and we're looking to test them in the future. Our relationship with Bosch Linde would allow us to test those modules. So the current system that we have in Bangalore with Shell is really like a test bed to prove the technology, and we've got 9 atmospheric modules in there, and you can play different tunes on those. But the work we did with Atkins Realis on, well, how do you scale something from a megawatt to a gigawatt? You have to do it in blocks of 10, and a module size that makes sense is 10 megawatts, because 10 megawatts to 100 megawatts to a gigawatt is a sensible building block. And that's what we're planning in the future. So our relationship with Shell does a couple of things. One is obviously test bed for technology, which gives people a lot of confidence. Secondly, it's a clear voice of the customer, so it helps us with the design of the module. And then thirdly, how do we scale that with partners into something that could then be deployed? So at some stage, well, next stages for us will be pressurized system development, getting that on test, and then also potentially in the future, a pilot facility, maybe with people like Shell involved as well, where we can prove it out at that 10 megawatt kind of level, and then it scales from there. So that's what's on our kind of product roadmap in the future.
Excellent. I did note that in that Shell contract for the 10 megawatt design, it does talk about pathways for commercialization with Shell. So that's presumably what you're alluding to there.
Yeah, and also when I talk about that voice of the customer on the pathways, we look with Shell at levelized cost of ammonia, synthetic fuels like synthetic methane, synthetic aviation fuel, etc. So it's not just Ceres saying this. We work with partners to look at what I talked about earlier is it's not about how much does our module cost to make. It's what does that enable in terms of the end product. And people aren't buying electrolyzers. They're buying hydrogen molecules, or they're buying ammonia, or they're buying steel. And that's what has to get down the cost curve.
So we're coming back to that levelized cost, aren't we, that we talked about a bit earlier. Okay, great. I want to talk about AtkinsRéalis a little bit because it's a very interesting presentation you made available to analysts and investors earlier this year. You've been working with them for a while, and the key thing here is to work on an optimized system design architecture for a 100 megawatt electrolyzer system that enables gigawatt scale plants. I wanted to ask you sort of how that's gone. Are your other partners all sort of involved, or at least have access to see that work as it's been done, so they can think about how they're going to potentially scale? I wanted to ask you also, are you involving any EPC partners in that process as well? Because obviously you've got a bunch of stack manufacturing partners, licensees now in various parts of the world. At some point they're going to want to build obviously 100 megawatt systems for their customers. Do EPC contractors get a look-see at what AtkinsRéalis is doing and then sort of interact with some of your partners for when that time is ready to be able to deploy and scale?
Yeah, I mean, we worked with AtkinsRéalis on that study as a pathway, a building block for others to use. So we funded a lot of that work ourselves. Or co-funded with Atkins, and we're free to use that with other partners. And that also helps inform our product roadmap. So if you look at the result of that takes us back down this modular pressurized approach. So from a product point of view, that's the first building block that gets us to that endpoint. But we started with, I think this is somewhat different, is we started with the endpoint and said, okay, a proof of concept with Shell at a megawatt's all very interesting, but what does it really take to scale, and to scale to hundreds of megawatts to gigawatts? And that's what the AtkinsRéalis blueprint work has done for us. We've learnt a lot from it as well, around, because of our temperature range, we can centralize a lot of the balance of plant in a way that some of our competitors can't because they're high temperature. So again, going back to that low cost steels, etc., it affords you to be able to centralize heat exchangers, blowers, pumps, compressors, etc., because you're not having to build in exotic materials, and the modular approach scales really well. And yes, when we talk to people like Shell, they also have EPCs that they would want to use. So again, we can make that available to different EPCs. When you talk about an EPC, well, AtkinsRéalis is one of the biggest EPCs. Thermax is an EPC, but a much smaller one. And then, there's the usual names in that industry that Shell works with as well. So yes, we are having more conversations with EPCs as a necessary point in that value chain I discussed earlier. But ultimately, it's a means to an end for Ceres, because what we're trying to do, a bit like ARM in the chip industry, is we go to the end market and we create the market pull for our licensed partners to lay down the manufacturing capacity. And EPCs are obviously part of that value chain. So the design that we've done with Atkins Realis, that EPC is totally transferable to others as well.
Very interesting. The last topic I'd like to cover is to look at the ability of customers to have confidence to be able to scale with the Ceres technology. We've talked earlier in this podcast about the fact that you are establishing a really, really low cost, if not the lowest cost, levelized cost of hydrogen through low capex, low opex, high efficiency technology. Looks like you're making great strides on that process and obviously beginning to test and trial with partners. And clearly your licensees have tested as well, and they must have confidence to have gone down that path of licensing your technology. With Atkins Realis, as we just discussed, you're now modeling, designing for scale. And you're involving obviously your partners and EPCs and potential future customers of theirs in that work as well. So cost and scale are areas that obviously great strides have been made. In terms of actually getting to the point at which the customers are going to be ready to and have confidence in deploying at scale, albeit we've talked about the fact that many of your licensees are going to be building manufacturing capability over the next 2 to 3 years. So we're really looking at a sort of 27, 28 and onwards capability. Obviously, system reliability is going to be key, as is operational understanding of using these systems, knowledge of degradation, confidence in long-term operating performance, and general maturity of the technology. And of course, that technology has to be bankable, because once we start getting into 100 megawatt and multiples of hundreds, we're talking about hundreds of millions of dollars of capex being involved. So I guess my question is, the first 2 of those 5 points, the cost and scalability, quite a lot of work gone on.
Yeah.
How do you see the next 3 points, this sort of maturity of tech, testing of tech, confidence around operating performance, how do you see those beginning to be accelerated over the next sort of 2 to 3 years, such that once we get to that sort of 27, 28 time frame when equipment's ready to be manufactured and deployed at scale, customers of your licensees can have that confidence in the technology's capability?
Yeah, I think that's the hardest part to accelerate. You can't really compress maturity. It's like you're trying to compress time almost. But as I was alluding to earlier, we're building out a very modular technology. So if we start with the cell and stack, we've got all the heritage of the SOFC side, all the thousands of hours that we have data on performance of that, the quality data, the manufacturability data, all of that is directly applicable to the electrolyzer side. So if you start at the stack level, we start with a very good foundation. To try and invent a time machine to accelerate that, we use digitalization. And Caroline Hargrove, who's our CTO, used to do the digitalization for McLaren, so Lewis Hamilton's twin race car. The issue that you have in hardware, deep tech kind of industries is how long it takes you to innovate something, build it, test it, learn from it, run it for... We don't have the luxury of running this for 8 to 10 years. We're going to have to predict how that is going to perform. And what we do is we combine digital models with test data, live test data, to predict future performance and also to inform our technology roadmaps and future product roadmaps. So we do that at the stack level. Start to do that at the system level as well, a lot of modeling, etc. And then, as I mentioned, a lot of the balance of system and plant is going to be common to electrolyzer plants, whether it's alkali, PEM, etc. So it's really where our focus is really at that what we call the stack array module level, which is the core element of the solid oxide that would then go into these plants. In terms of the bankability, that's a really interesting point, because this is one of the fundamental reasons why we have the business model that we have, which is if you are a steelworks or if you are a refinery, etc., your bankability has to be underwritten in some way by the provider of that equipment. You need a pretty big balance sheet to do that, and that's where our licensees come into their own, I think. So it's not Ceres' balance sheet, which, even though it's healthy, is not of the scale of a Denso or a Delta or a Bosch. So I think this industry is going to go through scale up. It's going to go through consolidation. There's a lot of, in my opinion, there's too many small players propped up by lots of government grants, and everybody wants to have a play in this industry right now. But if you fast forward 5 or 10 years, the winners in this industry are going to be the same kind of scale, the same kind of balance sheet that we need for major infrastructure type investments. And that's where the bankability will come from. It'll come from our licensing model. So we will, when we do a license, what we stand behind, what we underwrite, is the design of that technology, the performance of that technology. But the manufacturability, the supply chain, the scale of that really comes to our licensing partners. And so it's, in the next couple of years, it's about giving our licensee partners confidence in the maturity of our technology that enables them to go and fulfill their contracts with the end users.
It's going to be fascinating, Phil, to continue to watch. It's been fascinating to have the discussion today, and thanks very much indeed for coming in again.
Thanks, Nick.